so the assignment has two parts. Show you how to do part A, and then I'll show you how to do part B. If you are taking notes, do not write what I'm about to write. Okay? That's why I have it covered up. I just want to show you in general. So, let's say you have this problem. Tangent of theta equals 1.5. Yeah? Now, let's assume that I only want one answer. If I only want one answer, I would just do inverse tangent of both sides. And I would get inverse tangent of 1.5. Yeah? Then you plug it in your calculator, and you get whatever. Okay? Shoot. Delete. 1.5. So 56.3 degrees. Why does that sound so familiar? Yeah? Only one answer. Now, voila, let me come back. Now you can start writing. So let's say you have this same equation, but this time the directions say state the first 5 positive answers. Yeah? So this time you're going to take the arctangent of both sides. Arctangent is essentially the same thing as inverse tangent. There is a difference though. Arctan, like that. Just like with inverse tangent, you do not have to show that, and I would rather you not show that, to be honest with you. So all it does is this cancels this, like that, and then you get this. Theta equals the arctangent of 1.5, like that. Yeah? And as you just saw from the previous video, what you're going to do, or previous sample problem, you're still, on your calculator, going to go inverse tangent. And that'll tell you the first positive answer. So, oh, hold up. Let me show you the formula first. The formula is stupid, by the way. Voila. Okay. Arctangent is the same thing as inverse tangent. Except this, if you plug it in your calculator, it gives you one answer. If you want future answers, you have to add 180 degrees. That'll give you another answer. If you want another answer, then you add 2 times 180, or 3 times 180, or 4 times 180. So that's why the formula has this n in it. N means how many times, or how many answers you really want. Yeah? So this would be n equals 0, n equals 1, n equals 2, and so forth. This would be like n equals -1. Yeah, so this is called the general formula or general solution. General solution or formulas. Each book is different. I think our book refers to it as the general solution. And now what you're going to write are the approximate solutions. We know it's 56.3 was the first one. Like if I plug this into the calculator, that's what it's going to say, right? And then I just have to add 180 to that. If I want to go backwards, I subtract 180. Okay, hopefully you can see that. Yes, you can. Let me turn on the light, see if that helps at all. Oh, no. How about over here? Hey, that's better. Yeah. So, 56.3. That's the first answer. Add 180. That tells you the next answer. Next answer. Next answer. So you write comma 236.3 comma 416.3 comma 596.3 degrees. It's a degree problem, so make sure you write degrees. 1, 2, 3, 4. I think the first couple problems say state the first 5 positive answers. So please, if you can, put it all in a row or in a vertical column. You'll see why when we get to arc cosine and arc sine. By the way, arctangent is the easiest one of the 3. That's why we're starting with arctangent. And then you put a dot, 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 because it goes on forever. Yeah, yeah. Okay, and then I'm going to do 1 radian problem for you. 1 radian problem. Here's a major difference. X instead of theta. Theta means degrees. Typically 4.20. Okay, and you're going to take the arctangent of both sides. So you get that. Yeah. And then arctangent is the same thing as, essentially the same thing as inverse tangent. Voila. That only tells you one answer. To get future answers, this is a radian problem. You cannot use 180. You have to use pi n. N is the number of answers, basically. Yeah. Not really, but it kind of. Ta-da-da. So that is the general solution. General solution. And then you plug it in your calculator to get the, I forgot to say, these are called the particular solutions. Okay, and I show you. Clear. No. How do I not? Why is it not clearing? Clear. Okay, make sure you're in radian mode this time because it's a radian problem. And then inverse tangent of 420. Inverse tangent of 420. 4.2 is 1.33. So the first particular answer is 1.3. I'm not sure what the directions say. Usually when you're dealing with radians, they want 4 decimal places. But I'm going to be a little bit lazy and just write the first 3 numbers. Yeah. Okay. And then I'm going to add pi to that. Now, this calculator does not have a pi button, so I'm just going to add 3.14. Good enough approximation. Matter of fact, I should have just went, yeah. Let me go there. So 1.34, enter, add 3.14, that's pi by the way, and I get 4.48, and 7.62, and 10.76, and 13.90. Let me 1, 2, 3, 4, 5. These are radians, so you don't need a label technically. There. So, recap. If you're doing a degree problem, you need 180 n. Radian problem, you need pi n. Arctangent is essentially the same thing as inverse tangent. Matter of fact, some calculators don't have an inverse tangent button. It has an arctangent button. And when you press the arctangent button, you would think it would give you a whole bunch of answers. But guess what? It only gives you that one answer. So, even some calculators treat arctangent and inverse tangent as the same thing. Matter of fact, the calculator on your computer probably treats it as the same thing. Meaning it probably doesn't have this button. It probably has arctangent. And, by the way, sometimes they abbreviate arctangent like this. Just saying, I saw that the other day. I went, what is the ATAN? A-tan is not what you get when it's sunny. A-tan is arctangent, abbreviation. Yeah, I just made that joke up on the fly. Yeah. Okay, so that's part A of the assignment. You have to write general solution and particular solution. By the way, let's say you see some weird notation over on the side like this. 0, 2 pi. Here's what this means. It means only tell us the answers that are between 0 and 2 pi, or 6.28. So if this were the case, only the answers between 0 and 2 pi would be this guy and this guy. We would not write any of that. Okay? So some of the problems in your assignment have this notation written up over on the side, and it literally means, I can't remember what that's in, it's like epsilon or something. Tell us the answers for x that are between 0 and 2 pi. That's what it means. Yeah? Part B. There are 4 problems like this. 2 of them are degree problems. Make sure you look over here carefully, because then if it's a degree problem or a theta problem, you need degrees as your label. Okay? It does not have the actual equation that goes with the picture. I put it here. Let me rewrite it to show you what's coming on either tomorrow's lesson or the next day's lesson. I haven't honestly decided if I'm going to have you guys do 2 or 3 assignments this week. I'm leaning towards only 2. So the second assignment, remember, let's go back. That's an equation. Very, very basic equation. Here are some of the answers. That's an equation, a very, very basic equation, and here are some of the answers. Yeah? So the goal of this unit is for you to be able to solve more complex equations like this. And here's how you do it. You think of it as a system of equations. So this would be your first function. This is your second function. So if you had a calculator, this would be your y1, this would be your y2. Put it in the calculator, press graph, and that's what you get. That's what you get. Put that in the calculator, press graph. That's what you get. And the answers, by the way, this works on every single type of equation imaginable. This is how I taught my son how to check his answers to all equations in all his college level math classes. Is you just treat it as a system of equations, graph them, and see where they cross. So let's see where they cross. Crosses there. That's about, I'm going to call it, I don't know. Shoot. Now, and I'm going to write the answers in order from left to right. What number is between 30 and 60? Negative 45. Degrees. And here's the next answer. 45 degrees. Here's the next answer. What number is in between 120 and 150? You're just estimate. See? Estimate. Let's see. 270, 135. Okay, it appears that the period is 90 degrees. Yeah? So you're just adding 90 each time. I don't even have to look. Watch. Add 90 to this. I'm not even looking over here. I'm going to add 90 to this. And 5, 12, 225. Bam. I bet you that's what it is. 225. Yeah. 1, 2, 3, 4. So on these type of problems, you only have to tell us the answers that you can see in the graph that we show you. Simple. These problems literally will take you 5 seconds each. And we're not going to scare you and tell you what the actual equation is, because that's coming later. But pretty cool. Yeah. Frequency 2, so period is 180 divided by 2, which is 90. That's one way I kind of knew to add 90, and get 90, but it's kind of obvious from the graph too. So if it's a theta problem, make sure you write theta. is approximately equal to in degrees. If it is a radian problem, actually write x equals, or x is approximate. Yeah. And there you go. Hopefully I did a decent job explaining. I'm a little bit nervous about this part, so you might want to rewatch this. General solution. Plug it in your calculator to get the first answer, and then add either 180 or 3.14 to get future answers, subsequent answers.